Howdy boys and girls, Coop here with my newest tutorial covering a 3D world generator. I'm just going to give you a quick look at the end result here. So this is what we should be achieving once we've scripted it all. It's just a very fast and smooth sort of world generator. It takes a flat world, puts a bunch of terrain in it, and then spawns all sorts of cool little objects over the top of it. In my case, some horrible looking trees and stones and hills and whatever. This is what we should be achieving, something that will just populate your world with objects and items and things like that. This is actually a tutorial I've already written up on my blog. I did this as a written tutorial back before I was too confident with doing spoken or video tutorials, but I thought I'd redo it now just to give you guys a bit of a look and hopefully talk you through the script and how it's done. This is a bit of a long one. I do apologize. I try to keep them short, but it just never seems to happen. So please stick with us. There's a lot of information in here, and the script, although it's fairly simple, it is a bit confusing at first. So I'll do my best to go through it with you. And yeah, thanks for watching this. Let's get into it. Alrighty guys, before we get started, it's important to sort of understand what we want this script to do and how it's going to work. It's a bit hard to describe it to you. You've seen it in action, but that still can be a bit hard to sort of translate into what we're actually going to be writing here today. So I've done this exceptionally talented picture here in Paint that I'm hoping will clear things up a little bit, though looking at it now it's probably not making a hell of a lot of sense. So with all programming, if you have a good idea in mind of what you're trying to achieve and a plan for how you're going to achieve it, you will find you'll have an easier time of things. So I thought I'd just quickly try and describe what's going to be happening in this script and how the world generator actually functions. So when we get started, one of the first things we're going to be creating is something to represent our world, our ground. In this tutorial I'm going to be using a cube object that we've just flattened, made it very short. It's not a tall object, and it's going to be scaled out so that it's quite large. So it's going to be very wide and very long, but it won't be very tall. Across that object we're going to be spawning all of our terrain and trees and rocks and that sort of thing, as you may have seen in the intro to this video. Two other objects that we're going to have that are very important are going to be two markers that we're going to use to represent the very bottom left, so the BL marker object, that'll be the very bottom left of our world, and our TR marker, which will be the very top right of our world. So if you can imagine that we're looking down on the cube as a square, so imagine it in 2D, although it's a 3D object, just imagine you're sitting above it looking down at the cube. You've got a very bottom left of that cube and you've got a very top right of that cube. So in terms of sort of the coordinates, this is going to be sort of, let's say, x minus x and minus y, and this will be plus x and plus y. So we're going to treat that cube like a grid, although it's not going to have anything on it to represent that. Ideally, the way the script is going to work is it's going to start from the very bottom left corner, and going in hops or increments, I guess, it's going to work its way along the cube, finding points along it until it gets to the end, and then it's going to loop back around, start from the next point up, and continue to do that. So as I've sort of written here, you can see these are sort of where our spawn points will be, or where they'll start from. As the script runs, it's going to find each point. It'll apply some randomization, so the object should end up sort of somewhere within here, and then it'll spawn the object. For the purposes of this tutorial, or for the purposes of the script, I'm breaking the grid up and calling all these points sort of moving horizontally along this. We'll call that a row. And moving upwards, all the points upwards, we're going to call a column. And this here is when I refer to an increment or an inc, this is what I'm referring to, is this space between the points. So I hope that makes a bit of sense. Just to quickly recap, the idea is we're going to start from the bottom left, move along, spawning objects sort of randomly around these points. Spawn an object, spawn an object, spawn an object, move along. Once we hit the end, we're going to move back up. We're going to move up one and back at the start, and then we're going to continue. We're going to do that, and each time it runs through this and completes the whole grid, we're going to call that a pass. So one pass through the world will be from the bottom left right all the way along until we hit the top right, and that'll be one pass. We're going to repeat that a few times. Now we'll make that a lovely variable that you can set, something you can change in the editor, so that if you want the world to be more densely populated with objects, you can increase that, tell it to do say 20 passes through the level, and if you want a less populated world, so resources and stuff more sparsely distributed throughout the world, will have a lower value. So you'll see a lot of that as we go along, and I'll try to explain what we're doing as we're doing it. But yeah, like I said, it just sort of helps if you know what you're trying to achieve here and how the script is functioning. It'll just help you as we write the script to understand the functions that we're using and how we're using them, because ultimately that's the aim of this. I'm not trying to show you how to do this, the perfect way to do this or the best way to do this. I'm just trying to give you a good understanding of how this is being achieved, so you can better understand the functions and better understand the scripting, so that you can take that knowledge away and try and write something of your own and then hopefully improve upon it and do far better than I've done here today. So yep, I'll get into the scene now and just show you sort of a couple of the basic things that I've got set up, and then we can get started. Okay, so like I do every time, I'll just quickly run you through what I've got set up in the scene already. It's a relatively new project. I've set it up for 3D, as this is a 3D world generator, I guess, a 3D project. You will need a couple of things in order for this to work. You don't have to use exactly the same sort of objects I'm using here. You can provide your own models or your own objects, whatever you want to use, as long as they're not, too bizarre and have like weird points for the center or anything like that in the models. You should be okay. So if you have some tree objects or rocks or whatever, feel free to use those. You shouldn't have to change too much to get them to work, if anything at all. So in the scene already, I've got the main camera and a directional light, just so we can sort of see what we're doing. I probably won't be showing you much through the camera itself. When we run this at the end, I'll just show you in the scene view, just so you get a bit of a better look at what's going on. But yeah, feel free to have a camera, position it however you want, doesn't really matter. In the project itself, I have a couple of things. I'll start with the prefabs. So all I have here are some very basic shapes to represent some different objects. The important thing to note here is that I've got, it's sort of theoretical at this point, but it'll come into play more once we actually start writing the script. I have what we will call some terrain objects. So when I refer to terrain throughout this tutorial, and when we write terrain into the script, what I'm talking about are, say, hills or some mountains, which in this case once again are represented by some very basic shapes, nothing flash. The important thing to note is that the terrain objects are what will spawn first. So when our script does its first pass over the world, it's going to spawn the terrain objects before it does anything else. And the terrain objects ideally shouldn't overlap each other. They shouldn't spawn on top of each other. It'll just run through once, put in a bunch of hills and mountains and whatever, and then on top of that everything else will spawn, or more correctly, the objects that we spawn after that will be able to spawn on top of these things. So you might have trees spawning on the top of your hills and mountains and whatnot. The other objects I've got are what we will call throughout this tutorial world objects. So this can be something like a stone, a lovely cube there, or some trees. As you can see, these are some wonderful looking trees there. Fantastic modeling skills on my part. These are littler things, so you can use anything you like. They can be trees, bushes, small buildings, or bigger buildings, whatever you like. These will spawn a lot closer to each other, and like I said, we'll be able to spawn on top of our terrain objects. So this is what our world is mostly going to be populated by, is these smaller objects there. An important thing to note is all these things should have colliders attached to them. We will be assigning them to some tags and some layers a little bit later on. But yeah, as long as we need to make sure that they do have colliders in some way, shape or form. It'd be best if those colliders can sort of represent the overall shape of the object, but depending on the shape of the object itself, you may just sort of have to find what works best for you. So in my case, for an example, for the trees, I actually have them made up of two different objects. I believe both of those objects actually have colliders attached to them, so the top of the tree has a sphere collider, and the trunk of the tree, that'd be the best word, has a capsule collider attached to it. You're sort of going to have to see what works best for you in this regard. So if you have a really detailed tree model, for example, just sort of do the colliders the best you can, and if you find that you're having problems when the script's actually running, then you might need to go back and modify those. But it really depends on what you're using and how you want it to be set up. Shouldn't matter too much though. For the purposes of this tutorial, we're trying to keep it as simple as we can. So I have them in the scene already. We'll get rid of those in a sec. This is mostly just so I can show you what's going on. We don't need those added in already. As long as you have the prefabs though, that's what matters. I also have some materials. Don't need to pay a lot of attention to those. All they are just materials that are giving these objects the colors to give you a good idea on what they are, and just sort of make it look a little bit nicer than just having some very blank, horribly colored shapes in there. That's pretty much it. In the next step I'll be showing you a couple more things that we need to set up before we can write the script. Just some basic objects that will allow the script to run, and things that we'll be using to determine the size of the world, as well as the actual ground or the world itself. So we'll get into those now. Okay, now that we got all the boring stuff out of the road, let's get on to the fun stuff. First thing we're going to need is a cube for the ground, so I'm going to go to Game Object, 3D Object, Cube to add a cube. There it is. We'll position that in the center of the world, so we'll say 0, 0, 0. There it is. So we're quite far away, I know, but bear with me. We're going to adjust the scale a bit, so let's make it quite wide. We'll say an X value in scale for 50 and a Z value of 50, just to widen it out a bit there. And for the Y value, we'll just shrink that down a bit. We'll say 0.2 should be sufficient. Excellent. Okay, now we'll get rid of this white color too. I'm just going to drag and drop a material onto it. I'm using a light green there. Whatever you like, whatever works for you, it's not a problem. And of note as well is the fact that the cube does have a box collider attached to it. So whatever you're using for your ground, make sure there is a collider of some sort, because that will be important for the script. We're also, I'll get onto it now, let's go into Edit, Project Settings, Tags and Layers, and we're just going to add in a few tags and a few layers that we're going to need. The first of those, we'll add a tag that we'll call Ground, and we'll add two more. Second one we will add will be called World Objects, and we're going to add a Terrain tag as well, which I'm failing at miserably. Terrain. Actually, I'll make the tag World Object. I think that's what we'll be using. Good stuff. So Ground, World Object, Terrain, and we're going to do the same for layers. So we'll add in 3 layers, which we'll call Ground, World Object, and Terrain. Good stuff. Now let's go back to the ground object, which we should probably call ground. There we go, and we'll assign it to that tag, ground. Same for the layer. There we go, cool, that's set up. Now we want to do the same for our terrain and world objects that I spoke about before, our prefabs. So we'll select the 3 terrain objects I have here, and we will assign them to the appropriate tag and the appropriate layer. And now we're going to do the same for the smaller objects, the world objects. We'll do that there. That's because I have child objects on it, so I'm just going to say, yep, let's change all the children. You may not get that error if you're only using one object. Shouldn't matter. Cool stuff. Okay, now that we have that, and they're all assigned appropriately, we need 2 more objects. We'll just create some empty objects. So I'm going to create an empty game object there. I'm going to call that BL marker. So this is our first of our marker objects for the bottom left corner, and I'm going to duplicate it. And I'm going to call that one TR marker for top right. So our BL marker, we're going to set to, so what's this? It's 50 by 50, which would mean that the X position should be minus 25. The Z position should also be minus 25, that being half the cube, and we'll put it on 0, Y. So there it is there. So we're actually looking at this upside down. Let's just go around a bit and get over to this side, just so it's easier to visualize. I'll get these out of the road, just because they annoy me. That one can go away too. Go away, directional light. Don't need you yet. Cool, so if we go back to that BL marker, we can see it sitting in the very bottom left there. And for the TR marker, we'll do the same. Y value of 0. And the X position can be 25, Z can be 25. So that should be the very top right of our world. Good stuff. So we've got those two marker objects in there. We've got a ground object. Next we need one more object, another empty game object. We'll just position that at 0, 0, 0. And this one we're going to call world generator. So this will be the object that actually holds the world generation script. Good stuff. I believe that's all we need. So now that we have the scene set up, we have some objects in there, we'll get on to writing the script. Now, time to create the script. So we'll create a folder in the project, which we'll call scripts, and we're going to put the script in there. So we'll create a C# script, which we'll call world generator script. Awesome. And we'll get that one open. There we go. Alright. So the way this tutorial is going to work, it's a little bit hard to show you the script working until we've actually finished it. So I hope you can bear with me. We'll just need to write the whole script from start to finish, and then we can kick it off and see it in action. I'm not sure. We might have some points at which we can test it, but yeah, knowing the script, I don't think we will. So we'll just have to see how we go. Alright, first thing we're going to do is create some variables for it. There's quite a few for this script, but we're going to do them sort of in sections depending on what they do. So the first thing we're going to do is add in a comment, and we'll use this first set of variables. There'll be arrays that are going to hold all our objects. So we'll say arrays to hold objects that we will spawn in world. Good stuff. What are we going to need? We're going to need 3 of those. Now I'm going to break the world objects up into 2 groups. We have some trees and we have a stone. And the reason I'm going to do that is because we don't necessarily want them all to spawn with the same sort of frequency. Like, we'd ideally like to have more trees than stones. So, you know, say for every 5 trees it might spawn a stone. It'll just sort of make it look a bit nicer. It's mostly just to demonstrate to you that you can do this kind of thing as well. It's entirely up to you how you'd like yours to function. But I'll create those 2 arrays first. So we're going to make them private, but we want to drag and drop stuff into them in the editor. So I'm going to say serialize field to expose them. We'll say private game object array, and we'll call this one trees. And we'll do it again, serialize field, private game object array stones. Sounds good enough. And we'll need one more. This array is going to hold our terrain objects, so the hills and mountains and whatnot. Same again, serialize field, private game object array terrain. Sounds good. Good stuff. Okay, and to that as well, I'm going to create an integer, and this is going to hold a number that we will use to tell the script how many times to spawn trees versus stones, and it will do it by calculating a random chance, I guess. We'll see that in a little bit. So I'll create that now. We'll just say private int. What will we call it? We'll call it stone chance amount. We'll make that equal, let's say 5. 5 sounds like a good number, so we'll have a 1 in 5. Actually, we'll make it a 6, because we want it to be a 1 in 5 chance, and the way Random.Range works, we'll want it to be 6, so it's 1 more than the number we want it to end up with. Sorry, bear with me. Okay, next lot of stuff. We're going to create 2 game object variables to hold a reference to the BL and the TR markers. So we'll say marker objects. Once again, just adding a comment there to make it easier so we know what we're doing. Serialize field, private game object. We'll call this one BL marker. And we'll do it again. Serialize field, private game object, TR marker. Good stuff. Alright, next set of variables. What are we going to need? So we're going to want some variables that are going to control or basically we're going to calculate the size of our world. We're going to do that automatically, because if we, for example, change the size of that cube, we don't want to have to go in and change a bunch of variables. Where we're going to use the marker objects to tell the script to automatically calculate the size of that cube and where it needs to spawn. So we're going to have a bunch of variables that control all that. So we'll say spawning grid values, variables to control world size. You can put whatever you like into these comments. This is just something to help us remember what they do and where they're at if we come back to this later. We don't need to expose these to the editor, so we will say, what do we got first? We'll say private. We'll make these vector 3s, so private vector 3. First one will be current position, or current pos. We'll be using that'll be changing a lot in the script. That's basically going to be the position or the current point in the grid at which we're about to spawn an object. The next one will be, what should it be? Well, it'll be a private vector 3 again. And we'll say world object start pos. And we'll do another one, and we'll say private vector 3 terrain object. So we'll just say terrain start pos. Now these are going to help us, so it's a bit hard to explain. I'll just bring up that lovely picture again. There it is. Oh, fantastic. Now this was a bit misleading. So the points at which we're spawning at, so here's the BL marker down here and the TR. When we start spawning, we don't actually want it to start at the very bottom left. The way the grid's going to work, we're actually going to go up about halfway and in about halfway. I think that's how it's going to work, and we're going to be spawning probably closer to the center of these, or that's going to be our spawn location before we randomize it. The reason being that if we were to start here, and let's say the BL marker's on the very edge of the world, if we were to spawn there and apply the randomization, there's a good chance that the object could end up spawning off the edge of the world. And just for the calculations as well, it makes it a bit easier. So we're actually going to start about here, and the points are going to be sort of in the center of these squares. I didn't draw that because I thought that might be a bit confusing in the beginning, but bear with me. So that's what these variables that we're just writing are going to be used for. You'll see that coming into play once we start writing the script a bit more. Okay, we're now going to need another private variable. This one's going to be a float, and we're going to use this to store the width of the ground, so we'll call it ground width. What else do we need? We're going to want a private float again. We're going to have a world object inc amount. So this will be a variable to decide how frequently decide how far apart the world objects can spawn. Although they're going to get randomized, we're sort of going to spawn them at points throughout the world, the increments, and this is going to be a variable to hold that. And because we might no, actually, we'll split the terrain and the world objects up, because we may want the terrain to spawn much further apart than the world objects, because they're bigger. So we'll have two different ones, one for terrain, one for world objects. So we'll say private float terrain inc amount. And once again, all of these will be calculated automatically based on the size of the world. There will be a value we can set to tell it how frequently. We'll get that in a bit. And we're also going to say private float again, and we'll say world object rand amount. So this is a variable to tell it how far that randomized location should be. So ideally, like I sort of said, if we can imagine it spawning at this point here, we want it to be about halfway along, halfway up sort of thing, so that ideally each one should end up having like a square around it in which it can spawn. It will spawn randomly within that square, and each square should sort of just touch the square next to it. So that's what these rand amounts will be for, and they will be different because the world object and the terrain objects are going to have different increment sizes. The randomization needs to be different too, so we'll calculate all that automatically. Bear with me. So we'll say terrain rand amount, so similar to there. So there we go, world objects and terrain objects are both defined there. Cool. Okay, next set of variables, what are we going to have? So these are going to be some variables to control the actual looping through the grid itself, to control the spawning loop, I guess we'll call it. So we'll say values to control spawn loop through grid. Alright, first one we're going to want, are going to want to expose this one to the editor, so we will say serialize field. It'll be private, all of these are private. Rows and cols, so rows and columns. And helps if I actually give that a type. We'll make it an int, doesn't need to be a float. So rows and columns, and what'll be the next one? Actually, We'll use that one for the world objects, so I might just change that a little bit. We'll say world object rows and cols, and we'll do another one for the terrain. Private int terrain rows and cols. Cool. These are going to be the values we increase or decrease to control how densely populated the world is with objects. So I was talking about that before. These are going to be the values that we change to control that. And I should be able to show you those working once we finish the script. Okay, what else do we need? And now a couple of variables to control. Once again, serialized field, private. These are going to control how many passes over the world it does. So I was talking about the passes before. This is going to help us define those. So if we want our world to be absolutely packed with stuff, we're going to increase these values. So not only can we control how close together the objects spawn, but also how many of them spawn in total. And that's what these variables will control. So we'll make these ints. They just need to be rounded numbers. We'll say repeat passes. So how many passes after the initial one will it do? We do need at least one. You'll see a bit more of that in a moment. And we'll do another serialized field, private int, and a variable current pass. We'll call that one. This one here is just going to be storing a reference to the pass that we're currently running. So if it's the first pass over the world, this should equal 1. Second pass, it'll be 2, etc., etc. Good stuff. Okay, we've got those. Next, we're going to need some variables. So while we're spawning the objects, we're also going to be checking to see if we're about to spawn on top of an object or if we're going to overlap with anything. Ideally, we don't want that to happen. So we're going to be using some raycasts and another function called OverlapSphere that will help us control that. So these variables will be what we'll be using to control those. So once again, we'll do another serialized field. We'll say private float. And this will be sphere rad for sphere radius. That'll be for the overlap sphere and serialized field. Once again, whoops, no, yep, no private. That's I'm doing the right thing. Float. And what will this one? This will be a terrain sphere rad. I should make that world object actually. World object sphere rad. Cool. So once again, because everything's being broken up and the objects are all going to be different sizes, we do need to change these up a little bit. So they do need to be different from each other. Otherwise, we'll be calculating everything based on, say, the size of the terrain, which when we're talking tiny objects or smaller objects like trees and rocks and stuff, it's not going to be appropriate. So we'll create one for world objects and one for terrain, and as we've been doing up till now. And only a few more to go. We'll also make these serialized field. Pretty much all of them, well, most of them are. And these are going to be our layer masks, which we'll be using when we cast raycasts. So we'll say private. Oops. Helps when I do that right. Private layer mask. We'll call this one ground layer. And we'll do 2 more. Private. What? Nope, we want a serialized field. Oh my god, what am I doing? Serialized field, what was that for? Editor, Visual Studio, that was a bit mean. Another, we'll do a private layer mask. This one will be the terrain layer. And one more, serialized field, private layer mask. And this one will be for the world object, so world object layer. Good stuff. I think that's all we need for the variables. Sort of helps when I know the script to begin with. If you're writing this kind of thing from scratch, most of these you'd be working out as you go, as you work out what you need. Oops, we should put a comment in there as well, I think, just to say that those are the layer masks, so we'll do that now. Layer masks. Nice and easy. Cool. Alright, now that we've got the variables, so there we go there, that's all of them. Scroll that down a bit so we can see them all. Cool. Let's get on to writing the script. Alright, so the majority of the script is all going to be done inside 2 methods. The first of those is going to be a coroutine, just so we can sort of space it out a little bit. If we run it all just in one method, without any sort of like weighting or anything included in it, it's just going to try and run it all in one big go. The game's just going to freeze until it completes. It should all still work, it just won't look very nice. and we're going to also have another method that we will call every time we want to spawn an object, and we'll do the actual spawning of the object in that method. So we're not going to use the update function. I'm going to get rid of it. We are going to use start. So in start, like we did in the last tutorial, we're going to say start coroutine, and what should we call it? We will call it spawn world. Nice and easy. Oops. What are you doing, Visual Studio? Alright, cool. Let's define that coroutine now. Enumerator spawn world, brackets open. Good stuff. And let's get going. Okay, so what's the first thing we're going to need? Let's find the width of the ground, which we can do from the marker objects. So we're going to say ground width. Where is it? Ground width there is going to be equal to trmarker.transform.position.x, radio, and that's going to be minus blmarker.transform.position.x. So ideally it should find the distance, between the two objects, which should theoretically mean that is the width of our ground. Next thing we're going to do is set a couple of those variables that decide the distances between objects, etc. So all the rows and cols and the inc amounts and the rand amounts and blah blah blah. We're now going to work those out. So like I said, these are all going to be done automatically, and this is where we're doing them. So we will say the world object inc amount is going to be equal to the ground width divided by rows. World objects, rows and cols. So rows and cols is going to be the variable that tells it how close the objects are going to spawn. So if we break the world up into, say, 4 by 4, so 4 rows by 4 columns, we're going to sort of divide the ground width up by that. So if rows and cols is equal to 4, we're going to divide the ground width up by 4, which should give us a value that we can use to start calculating where all our objects are going to spawn. And we're going to do the same with the rand amount. So we'll say world object rand amount, where is it? There it is. Is going to be equal to the world object inc amount that we just set, world object inc amount divided by 2, basically, because we want to find half the distance between the spawn points. We're going to do the same with the terrain. So terrain inc amount is equal to ground width divided by terrain rows and cols, and terrain rand amount is going to be equal to the terrain inc amount divided by 2. We're defining we're saying that the 2 there is a float, just because when you're dividing numbers, you're best to do that by a float, or you can have erratic results if it lets you do it at all. Okay, next thing we're going to do is set the starting positions. So where on the grid we're actually going to be starting the spawning from. So like I said, we're not going to spawn necessarily from that very bottom left corner. We want to go up and in a little bit to try and make it all even out. So we'll set that now. So we'll say the world object, where is it? Start position, world object start position is going to equal a new vector 3. And that vector 3 is going to be blmarker.transform.position.x minus, open brackets, world object inc amount, divided by 2f. Yep, I think that's about right, because the starting position is actually going to be a minus value, so that should work. So that's going to be the X position. The Y position is going to be blmarker.transform.position.y, because the Y pretty much won't be changing at all. You could probably even just set that to 0, but you know, that sort of helps. And the Z value, what is the Z value going to be? It's going to be blmarker.transform.position.z plus we got that in brackets, world object inc amount divided by 2f. So that should do the trick, I believe. Sorry, I'm just having a quick look over that to make sure I've done the right thing. Looks good to me. Alright, now let's do the same with the terrain. Terrain start pos is going to equal a new vector3, and that vector3 is going to be very similar. BL marker dot transform dot position dot x minus the terrain. Was it terrain inc amount? Yes, terrain inc amount divided by 2. Once again, BL marker dot transform dot position dot y and BL marker dot transform dot position dot y plus terrain inc amount divided by 2f. There we go. Cool. Excellent. All right. So, now that we've got the starting positions defined, the next thing we're actually going to have to do is start writing the loop itself. So I'll do that in the next section of this tutorial, I think. Alright, so some of you might have guessed the way we're going to achieve this, now that you sort of know how the script is going to be working, we're going to be looping through the world. So the way we're going to do that is by using a couple of for loops. We're going to basically nest a for loop within a for loop, within an if condition, within a for loop. So there's going to be a lot of stuff happening at once, but ideally, because it's all happening sequentially, we should see it behaving the way we want, which is, you know, moving along point till it gets to the end, go up one, point, repeat. So let's get going with that one. We'll say for, we'll create a temporary int, which we'll call RP for repeat passes equals 0. RP, while less than or equal to repeat passes, we're going to say RP should increase by 1 each time it runs. Okay, within this for loop, we're going to say current pass, so that's the variable storing the pass that we're currently on. Current pass is going to be equal to that RP integer that we defined up here. So in the beginning, the current pass is actually going to be 0, and then every time it repeats through, the current pass is going to be 1, 2, 3, 4, etc. Cool, now that we've got that, we need an if condition. We will say if the current pass is equal to 0, so if this is the very first pass of the world that we are doing, sorry I got that wrong, double equals symbol for when you're doing checks. If the current pass is equal to 0, what we're going to do is say that the current position, so this is where we're just starting off, so the current position is going to equal the terrain start position. So what I'm doing here, we're going to use the very first pass of the world to spawn the terrain. As I sort of mentioned in the just at the start of the video, we want the terrain to spawn first, and then we want everything else to be able to spawn on top of the terrain. So that's how we're going to do that, is by saying if this is the very first pass over the world, then we spawn terrain, and our start position needs to equal the terrain's start position in the world. Good stuff. So this is where we're going to have another for loop. So for integer rows, which will equal 1 this time, because we're going to be starting on row 1. If we start from 0, it's not going to achieve quite what we want. So while integer rows equals, so for integer rows equals 1, while rows is less than or equal to terrain rows and cols, so the value that we've defined for rows and columns, it's going to probably increment, I would say. Sounds good to me. Cool. Good stuff. Inside that, we now need another for loop. So for int cols, so this is where we're doing the columns, equals 1. And pretty much the same thing. While cols is less than or equal to the terrain rows and cols, cols is going to increment. Good stuff. Okay, inside this for loop we actually get to do something a little more interesting. So we will say current pos is going to equal a new vector3. So we're changing that current pos each time this runs. So current pos is going to equal a new vector3, which is going to be current pos dot x plus the terrain inc amount. So we're basically saying take the x value, add the inc amount to it, and that's going to be where our new position is. And I think this can actually be current pos dot y, because that won't be changing, and current what have I done there? Nope, I got that wrong. That needs to be, yep, that's better. We don't need a semicolon there. And current pos.y and current pos.z. So those values aren't going to be changing in this part of the for loop. We're only incrementing the x value. Good stuff. So when this first for runs, it's going to take the current position and it's going to increment it by 1 along the x-axis according to the inc amount that we've created, and then it's not going to modify the y or the z values, not yet anyway. Okay, so now what we want to do is pick an object to spawn out of the terrain. So we'll be doing that. We'll say game object new spawn, so just a temporary game object value, and that's going to equal terrain, what did we call it? What did we call it? So it should be a terrain objects. No? What have I done? What did I call it? Ah, just terrain. That's what I called it. My bad. So yeah, terrain. There it is. The array. And which one do we want? We want, let's say Random.Range. And between 0 and terrain.length. So it should just pick an object out of that array randomly, and that's the object that will be spawning. So now that we've defined that, what are we going to do? We're going to run a SpawnHere method, which we'll be defining in a little bit once we've written these loops. So we haven't created that yet, so it's going to give us a squiggly line to tell us we've done something wrong. Ha! Joke's on you, we haven't. We know exactly what we're doing. We're also going to give that method some parameters, which once again we'll write in a little bit, but we need to put them in here. So just bear with me for these. The first parameter is going to be current pos, the current position. The second parameter is going to be the object, so new spawn. The third parameter is going to be the terrain sphere radius. And the last one will be a bool, which will say true. Cool, once we've done that, I'm going to chuck in a yield statement here. So yield return new wait for seconds, and we're going to make that value, what will we make it? Let's make it 0.01f. So once it's actually spawned an object, it's going to wait for a tiny fraction of a second there, 0.01 of a second, before it moves on to spawning the next object. So that'll give us a nice sort of drawn out spawning process, so you can actually see it happening in front of you. If we didn't include that, not only would the enumerator, the coroutine, have problems with not having a yield statement in there, but it would also try and run it all at once in one frame, and it would be horrible. It would just lag and freeze, and we'd be waiting forever for it to finish. You can actually adjust how long this whole process is going to take by where you position these wait for seconds and how much you set them to, but I'll show you a little bit of that later, and you can have a play around with that yourself to sort of see how it goes. Alright, that's pretty much it. After this for loop here though, we're going to add in something. So now that so ideally this here is just saying move along the x-axis until you hit the very end, which is the terrain rows and cols. That's what will define that. So once we hit the end, we need to reset that back to the beginning and move up 1 on the grid. And we're going to do that by saying current pos after this for loop has run. Current pos is going to equal a new vector 3, and that vector 3 is going to be the terrain start pos dot x, because we're just going right back to the start. Then we're going to say current pos.y, because that doesn't need to change, so that should be consistent, and current pos.z, plus the terrain inc amount. So that's where it's actually going up 1. So once again, the first for loop is going to run. That's our rows. Yep, so that's going to run. Inside that, it's going to go along the x-axis until it hits the end. Once it hits the end, it's then going to go back to the start and go up 1. And then it's going to repeat that process, basically, until it hits the very top right, which it will know when it's hit the top right, because it will, this condition will then basically be met. Good stuff. Alright, so that's it for the terrain. What do we need to do now? So we're going to go back to this if condition here. So once the current pass doesn't equal 0, so once it's done all this once, this is no longer going to be true, so we'll say else. So basically, for every pass that doesn't equal 0, so every time current pass isn't 0, which is any after 0, I wonder if we should make that, yeah, we'll make that an if condition. Else if current pass, not current pos, current pass, if that is greater than 0, and the reason we're going to do that is, so let's say you want the first 3 passes to spawn terrain. It's easy for you to set. All you got to do in here is just come in here. You could probably just remove that entirely, or just say if current pass is less than or equal to 3, and as long as this is greater than 3, greater than 3 would be a better idea. That'll actually allow you to modify all that. I'm sure you can have a play around with it to find what works for you. And I'll just set that back to equals 2, equals 0. Cool. So, if we're on the next lot of passes, we're basically going to repeat the same process. So, all of the above, but the only difference is going to be that we're going to be doing it with the world object values instead. So, current pos is now going to equal the world object start pos, similar to what we did above. So next we're going to need to start the for loop once again. For int rows, because we can reuse that, is equal to 1 rows. Int rows equals 1 rows, as long as rows is less than or equal to rows and world object rows and cols. That's what we want. What's next? We want rows to increment by 1. Don't need that. Start the loop. And inside that we're going to chuck another one. For int cols equals 1, while cols is less than or equal to world object rows and cols. Yep, cool. Cols plus plus. Done. Open the loop. Alright. So once again, we're going to make a few changes to the position. So current pos is going to equal a new vector3. That vector3 is going to be current pos dot x plus the world object inc amount. Where is it? There it is. World object inc amount. The next value is pretty much going to be the what do we use? We can use current pos. Is that what we used above, just to be consistent? Just having a look. Yep, we use that again. Current pos dot y and current pos dot z. Because once again, we're just working our way along. Hang on, have I done that the right way around? I think I've got them around the wrong way, actually. Sorry, bear with me. I suppose it's about the same, really. It shouldn't matter. I've just mixed up these here. So I'll just, I'll just change those. So I'll say cols, rows, and just swap them around. Because we're working our way along the row, not the column. So that's my bad. Cols. I mean, it doesn't matter, really. It doesn't matter at all, but, you know, this will just keep my brain happy. And just hopefully to make it a bit clearer. Yeah, because we're working our way along the rows, and then we'll be working our way up one in the column. I suppose you can look at it either way. Like I said, doesn't matter. Doesn't matter at all. Okay, where were we with that one? So we've just started that loop. We've said current pos. Yep. We've got that defined. That's all nice and happy. So the next thing we're going to need, similar to the above, is say game object. We'll call it new spawn again. Actually, no. Let's not do that, because now we actually need to break it up. We need a chance in there. So I was saying before that we don't want rocks, stones to spawn as often as trees. So we'll need to change that. We need to break that up a little bit. So we'll create a temporary integer, which we'll call spawn chance, and that's going to equal Random.Range, not random range, range, and that range is going to be between 1 and, what did I call it? Stone chance amount. Cool. Excellent. So basically it'll be a chance between 1 and 5 because I believe we set it to 6. Actually, better way of doing that, just to make life easier. So let's say 5. We want it to be between 1 and 5. So down here in Random.Range, we're just going to say stone chance amount plus 1. So we're taking care of that little issue with Random.Range there. So instead of having to account for it when we define the variable up here, we're just going to do a little calculation here to add 1 to it. So that should give us a chance between 1 and 5. Alright, we'll say if the spawn chance is equal to 1, so if we end up getting a 1 for that Random.Range, we're going to set the game object to be one of the stone objects. So we'll say game object, we'll call it new spawn again. It's going to equal an object from the stones array, Random.Range, between 0 and stones.length. So it's going to pick an object out of the stones array to spawn. Then we're going to run that SpawnHere method again. The SpawnHere method that we haven't created yet. So SpawnHere, current pos. Oops, no, current pos, not pass. Yeesh. Current pos. SpawnHere, current pos, new spawn is the object that we're going to spawn. We're going to use the world object sphere radius variable. And what do we need? We needed another variable. I'm going to say false for that one. If I remember correctly, that's going to be a little variable that tells it whether it's a terrain object or not, which will be doing different things based on whether it is or not. Okay, spawn here, and we're going to add in another yield return new wait for seconds. Same as before, we'll make that 0.01f. Whew, alright. Cool. So once again, all that yield statement is doing is just telling it to wait a little bit before it proceeds on to the next object. It's just for a visual thing, really. We'll do an else. So if the spawn chance ends up being anything other than 1, so if we don't get lucky and it's going to be a stone object, then we want it to spawn one of the trees instead. So we'll do it again. Game object, whoops, new spawn. It's going to equal trees. So an object from the trees array, and just repeating the same thing. Random.Range between 0 and trees.length. Good. Good. I reckon we can just copy and paste this. Good stuff. We can. Yes, we can. Good. And once again, we'll do another yield statement. Same thing. I'll just copy and paste that. Save us a little bit of time. There we go. Alright, cool. Yep. 4, that all looks good. Alright, and now that we've done that, we just basically, like we did above, we now need to increment the Z position. I think I've been calling it Y, not Y, it's got to be Z. Okay, so we're going to do that after this for loop here. Else, yep, close, cool, awesome. Current pos is now, why do I keep doing that? Current pos is going to equal a new vector3 again, and that vector3 is going to be the world object start pos, world object start pos dot x, world object start pos dot y, and world object start pos dot z plus the world object inc amount. Pretty sure it's all we need. Good. Excellent. So that right there is basically all we need for the coroutine, I'd say. Actually, we might add one more thing to happen after we finish the whole spawning process. We're going to kick off one more method, and that method we will also create later, and we'll call it world_gen_done. Now that is also, once again, another method that doesn't exist yet, but the idea of this is once the whole spawn process is done, once it's run through the whole thing, it's going to fire off this method here called world_gen_done. So basically that gives you some room. So once the whole spawn process is complete, you can tell it to do something else. So essentially you can wait for the whole thing to finish. Once it's done, it runs that method, and you can put whatever you want in there to kick off the game, or to spawn the player, or whatever. So ideally you won't have the player spawning in the middle of this world while it's creating the terrain around them or all that. You can just chuck it in this method here and get it to do it once it's done. Alright, that's the coroutine done, and I think we'll now move on to writing that SpawnHere method that we've been writing about so frequently. Alright, just before we go on to the SpawnHere method, I just wanted to correct myself on something. I may have made a bit of a mistake, not with the scripting, but just with the way I explain stuff. As you may have noticed when we defined the start positions, I did a minus here, and a plus there. So I sort of explained what was going on using this grid, in that ideally we wanted our first spawn position to be in the very start there, but I just explained it a little poorly, so I'll just correct myself now. The very start position is actually going to end up about here. The reason for that being that on the very first run, so the very first time we start doing the row, the very first point that it's going to spawn at, so the start position is here, and then when it goes along 1, it's actually going to end up jumping to here. So if we started from there, we would actually end up on that point there, which isn't ideal, because then we're spawning in sort of this radius here, and it'll keep doing that, but what it means is that we never actually end up having anything spawn along the edge there. So by adjusting that value, by going the x value minus and then the z value plus, we end up about there. So when it does its very first spawn, it's going to jump into the center of that square there and then spawn within here. So the square could be seen as sort of the spawn area that the randomization will end up spawning within. We're going to write that randomization into the SpawnHere method in just a second, but I just wanted to explain that as it might have been a little bit confusing. It just sort of ends up ensuring that our spawning positions are consistent. So once again, if we were to go along each point, we'd get to the end, and then it would still go along 1, so we'd end up spawning out here, which could end up off the edge of our world. So it just helps. It ensures that each one of these squares essentially represents our spawning area, and the object could be anywhere within that area once it's applied the randomization. Cool, hope that cleared it up. Alright, let's get into writing the actual SpawnHere method. So that's going to happen, we'll write it after this coroutine here, so we'll find the very end bracket. Not by doing that, we won't. That should be it there. Let's just check it. Yep, it's highlighted that one, so that's the right one. So we'll just go down a couple. Awesome, and let's start writing that method. So we're going to say void spawn here, and you remember we gave it a whole bunch of parameters when we were calling it, so this is where we're actually going to define what they are. So the first thing is going to be a vector3 new spawn pos, because you remember we were giving it the current pos, so that's going to be a vector3 there. We're going to give it a game object, which we will call object to spawn. In each case, that was the object that we ended up wanting to spawn, so that's it there. We're also going to give it a float, which is going to be the radius of sphere. That's the sphere that we're going to use to check for collisions, and we're also going to give it a bool, and that bool is going to be is object terrain. So is the object that we're spawning a terrain object, or is it a world object? And that'll be important in just a second. So alright, let's start the method. The first thing we're going to want to do is say if the object, or if is object terrain, so if we're spawning a terrain object. So actually we don't want it to be, so let's say yep, so if is terrain object equals true. Another way you could do that is just by saying that is terrain object. In other words, is it true? I like to spell things out in full. It just helps me a bit later when I'm reading through the scripts. So if it is a terrain object, then what we want to do is say vector3 rand pos, which is a new vector3 that we're creating, a temporary one, is going to be equal a new vector3, and that vector3 is going to be new spawn pos, so the parameter, the variable we gave it up there, new spawn pos dot x plus random.range, and that random.range is going to be between minus terrain rand amount, minus terrain rand amount. Yes, so that's going to be, yep, random.range, and the last one, the other part of that range is going to be terrain rand amount plus 1, just also once again accounting for that, the way random.range works. So that's going to be the x position. The y position is just going to be, well, we could just say 0 here, or we could just say new spawn pos.y, but let's just say 0. and the Z position is going to be new spawn pos dot Z plus and again random.range, and we'll do the same thing here, minus terrain terrain random amount, and the other side is going to be terrain random amount plus 1. Cool. So that, once again, that's giving us, so the spawn point is going to end up, let's say, in the center of this square here. All we're saying is that we want to make a range, and that range is going to be minus the x, or minus the random amount, which is going to be half the distance between the spawn points, so half an increment. So it should end up saying that the x range is between here and between here, and it's doing the same with z, between there and between there, which means that the object could spawn anywhere within this area. Excellent. So that's the new vector 3. Why is it giving me a squiggly line? I need an extra bracket is why it's giving me a squiggly line. There we go. Alright, so that's the rand pos that we just created there, and let's create another vector 3 which we'll call ray pos. So we're going to use this to cast a raycast. That's going to be new vector 3 again. Now this one's a little bit simpler. It's just going to be randpos.x. We'll say 10. We want it to start from a little bit above that spawn point, above the random position, so because it's going to shoot downwards, so we'll say 10 up in the air, so y value is going to go up 10, and randpos.z. So our raycast is going to be cast at the position of randpos downwards from a little bit above it. Hope that makes sense. Alright, let's put in an if condition. So, if physics.raycast, if physics.raycast, casting at ray pos, it's going to go downwards, so minus vector 3.up, which is essentially vector 3.down. There is no vector 3.down, so that'll do. We're going to cast it for mathf.infinity. That's going to be its distance, and we're going to use a layer mask, and that layer mask is going to be ground layer. So we're casting a raycast just to see if there is ground beneath us, and if there is, so in other words, if this makes some sort of connection, we're going to do a quick check to see if there's any terrain below us. So ideally, this should only collide if we are above the ground. So in other words, if we're over the edge of the world, it won't spawn anything. It'll just say, okay, cool, you didn't hit. I'm just going to move on and do whatever's next. Alright, so we're going to create a temporary collider array, just because we have to. Objects hit is what we'll call it, because it could end up being multiple objects that it hits, so we need to define that as an array. Ideally it should only hit one object, but Unity doesn't know that at this point. So we'll say physics. Actually no, sorry, this is for the overlap sphere, my bad. So yep, so we've cast the raycast, it's checked below it, it's hit the ground. The next thing we want to do is cast a sphere around us to see if there's any other objects around us. If there is, it's going to collide and chuck their colliders into this array. So we'll say physics.overlapSphere, and that's going to be cast at randpos again. We're going to use radius of sphere, so up here. So if this is a terrain object, that will be the terrain sphere rad. So it's going to use that. Radius of sphere is going to be how big the sphere is, and the layer that we want it to check for is going to be the terrain layer, because we're going to check for terrain objects. Cool. So now what we're going to say is if objects hit, there it is, so the collider array we just made, if objects hit dot length equals 0, so in other words, if there's nothing in this array, if we haven't hit any other objects, then what we'll do is we'll say game object terrain object, which is a new temporary game object that we're creating, is going to equal game object instantiate object to spawn. So we're instantiating an object and referencing it, calling it terrain object. So we're going to spawn that object to spawn up here, which when we're calling the method, oops, there it is. When we're calling the method, we're giving it the object that we're currently spawning, so that's where it's doing it. It's spawning it here. So we're spawning object to spawn. We're going to spawn it at randpos, so whatever the randomized position we ended up with is, and we're going to give it a quaternion.identity, just because, yeah, the randomization doesn't, the rotation doesn't need to change yet. Okay. What we might also do, let's rotate the object randomly. So we'll do that now. So rather than defining it up here, we've created the object, we've referenced it. So now let's call that object again and change its rotation. So let's say terrain object dot transform dot Euler angles is going to equal a new vector 3, and that vector 3 will be transform. Try that again. Fail. Transform dot Euler angles dot x, because we don't need to change the x rotation. We're going to change the y rotation, and we'll say Random.Range. That range will be between 0 and 360, so that it could be randomly rotated anywhere around that on a 360-degree angle. And we'll just say transform dot Euler angles dot z, because we don't need the z rotation to change. There we go. Cool. That should be all we need to spawn our terrain object, I believe. So now that we've done that, we'll go back to this one here. So where is it? So if terrain object, if is terrain object equals true. Let's have an else. Oops, what did I do that for? Let's get that bracket back in there. That was silly. Else. So in other words, what have I done? Why is it not happy with me? Ah, that would be why. My bad. Let's try that again. Nah. Alright, so if terrain object, if is terrain object doesn't equal true, so else. What are we doing in else? Else we will pretty much repeat the same process, but we're going to change a bunch of stuff, so it's actually a world object instead. So we'll say vector 3, randpos is going to equal a new vector 3 again, and it's going to be, what is it going to be? It's going to be new spawn pos, there it is, dot x. It's going to be plus random.range, excuse me, same as before. This time it'll be the world object rand amount. Where is it? There it is. And world object, you know what, let's type rand amount, that'll make it easier. World object rand amount plus 1. Go for the, yep, so it's the x value. Let's do the y value, which can just be 0, I would say. Yep. Did we need to change that later? Sorry, I'm just having a quick look. Bear with me. Actually, I might set that to new spawn pos.y, because I believe we actually alter that later. Doesn't matter. New spawn pos.y, and finally new spawn pos.z plus random.range between minus world object rand amount, where is it? There it is, world object rand amount, and rand amount again, world object rand amount plus 1. So exactly the same as we did for the terrain object, but just using the world object random amounts instead. We'll do another raypos, vector 3 raypos. It's going to equal a new vector 3, which is going to be randpos.x 10 again, just to make sure it's up in the air. Or should we set that a bit higher? Because it might actually, look, that should be fine. You know what, I'm going to set it a little bit higher, just in case we end up spawning on top of terrain objects. We want it to be able to cast downwards still. So we'll just make it a little bit higher in the air, just to account for that. And we'll say randpos.z. Cool. Alright, so we'll do another raycast. If physics.raycast, and that raycast will be at raypos. It'll be at raypos, yes it will, good stuff. Raypos, we want it to go down, so vector 3 dot up, or minus vector 3 dot up. It's going to go, actually let's do an out this time. So we'll say out hit, Hey, don't do that. You know what? I forgot to define hit. That's why it's giving me issues. Sorry. So just before we cast that, we're going to actually want, we're going to create a temporary raycast hit, and we'll call it hit. We'll be using that in a little bit to get some information about the object. So we do this a little bit differently, but we'll get there. Cool. So we now want the distance again, which will be once again mathf.infinity. And we'll make it the ground layer. Now I think ground layer is actually going to need to include the terrain as well in order for this to work. It's not a big deal, we'll be setting those up in a little bit. So we'll say ground layer, cool, so it's going to look down, it's going to check if it hits anything on the ground layer, then this condition will run. Okay, randpos equals new vector 3. So this is where we're going to change things a bit. I remember what I'm doing now. So when we cast this raycast down, if it hits one of the terrain objects, for example, we want to adjust the random pos. So although it's randomized on the x and z values, we now are going to need to change that y value. So if we hit a hill, for example, it's obviously not going to want to spawn on top of the ground. We want it to spawn a little bit up. We want it to spawn on top of that hill. So this should help us to do that. So we'll say randpos is going to equal a new vector 3. That vector 3 is going to be randpos.x. The y value is going to be the hit.point.y. So where this raycast is hit is where the y value is going to set itself to. It's going to set itself to its y value, and randpos.z. So essentially we're just changing that randpos to account for if we've hit any terrain object. It's going to adjust the y value to put it on top of that terrain, because the point at which it hits should be on the top of the object. Alright, now once again we'll do another collider array. So like we did last time, we're going to cast another overlap sphere. We can call that one objects hit again. Objects hit is going to equal physics.overlapSphere. We'll cast it at randpos, not raypos. We'll use the radius of sphere again. And we'll cast it on the world objects layer. World object layer, there it is. So this is basically going to check to make sure it's not overlapping with any other world objects. Cool, so we'll now do another if condition, same as before. So if objects hit dot length equals 0, so if we haven't overlapped any objects, then we're going to do similar to above. We're just going to change a couple of things. So let's see, here we go. Game object, we'll say world object. So similar to what we did above, game object, instantiate. Once again, we're instantiating an object and storing a reference to it. The object we're going to spawn is object to spawn. We're going to spawn it at randpos. And we're going to do the quaternion dot identity as its rotation once again. So there we go. So we spawn the object. So next thing we want to do, just having a quick look, we probably want to just do a little bit to try and align it and make sure that it's not going to sink into the ground. So this is probably helpful if like you are using an object that has child objects attached to it, that can throw this off. So we're just going to do a quick calculation to ensure that it doesn't spawn halfway down in the world. We'll do that by saying the world object that we just created above, the world object.transform.position, is going to equal a new vector 3. Type that a lot, and that vector 3 is going to be world object dot transform dot position dot x and world object dot transform dot position dot y plus open brackets world object dot get component. And in that, we are going to call the renderer attached to the object. renderer brackets dot bounds, so we're finding the boundaries of that object using its renderer, because that stores that information. Dot bounds dot extents, so so the extent of those boundaries, I guess. Dot y, so we're basically finding the height of the object. So we're finding the height of the object, and we're going to say times 0.7f. So it will actually sink it into the ground a little bit. It'll sink it by 0.3 of that object. So that'll just help with the trees and the rocks and stuff like that. So let's say it spawns on the edge of a curved surface, so the hills are curved. We want it to sink into the ground a little bit so that it doesn't jut out over the side and you can see the underneath of the object. So that will actually do it. So this is basically just saying, adjust the position of the object. So its Y position is going to be I think, do we actually need to, we need to plus, that's correct. Oh, apologies guys, it's been a while since I wrote this script. I'm trying to remember it as I go. So it's going to take that Y value of the object, and what it's going to do is just adjust it a little bit, because I believe it will start sort of halfway sort of in the ground. It's then going to add to it and say take the size of the object, take 0.3 of that object, and then sort of increase it by that value, which is what this is doing. If that's a little bit confusing, once we're done with this script, recommend come in, change it, play with it, just see what sort of results you end up with, because that really is the best way to get a good understanding of what's going on. If you increase the value, you will see it. You'll see the object's position change rather drastically. So just bear with me just as I do, and have a play with it later. It should make a lot more sense then. And once again, we'll set the Z value of the object. So the world object dot transform dot position dot Z. There we go. So we've adjusted the position of that object to account for whatever it has spawned on top of. Okay, last thing we want to do is similar to the terrain object. Let's give it a randomized rotation. So world object dot transform dot Euler angles is going to equal a new vector 3. I like using the Euler angles to adjust rotation. I just find it a lot more human readable. It's a lot easier to understand. If you're not entirely familiar with Euler angles and the functions that we're using here, so what we're actually doing, rotating it using a vector 3, do a bit of reading on it. It's a very good thing to understand. Understanding Euler angles is incredibly difficult at the best of times, but yeah, it is something that you'll need to do often when you're talking about rotations. And like I said, I just find this a hell of a lot easier to do than using sort of the transform dot rotation and that sort of thing. So we'll say new vector 3. That vector 3 is going to equal the transform dot Euler angles dot x, the transform random dot range, and exactly the same as we did above, between 0 and 360, and transform dot Euler angles dot z. There we go. Cool, so that's adjusting the rotation of the world object that we just spawned, and we're doing that after we've spawned it. So that's what this reference here comes in handy for. So we basically reference it, and then we can modify the object after it's spawned, and you won't really notice that happening. It's all going to happen really fast, and it'll just happen as part of that one method. So it won't look weird. Hopefully, it should just work. Good stuff. That's pretty much it, guys. That there is the bulk of it. That's where we're doing all the magic, all the fun stuff. It's all happening within that function there. So the IEnumerator, the coroutine, is just creating and setting that position for us. It's just looping through. It's running across the world. It's creating a position for us to spawn an object at, and then looping and doing that pass. And then each time it needs to spawn an object, the SpawnHere method is where the magic's happening. So this is actually taking that position given to it by the coroutine, it's randomizing it, then it's spawning an object, and then it's altering the position and the rotation of that object in order to sort of line it all up and make it look a bit nicer. Once we're done with all that, we need one more thing. We're just going to put that on the end of this SpawnHere method, which I believe should be after that bracket there. It is good. And that is, we're going to write the void world gen done. So like I said, this method here, void would be better. not void or whatever the hell that was. Void world gen done is a method that is going to run once all of this is completed. So once this coroutine ends, it's going to call this method, and it will do whatever you tell it to do. For the purpose of this tutorial, all I'm going to put in there is just print world has been generated. We're really excited because it's all done, so we're going to use 3 exclamation marks, and then we're even going to put a hooray because we're cheering. And that's it. That's done. That's the whole thing. Thank you for sticking with me throughout all of this. Well, that's the script at least. We still need to change a couple of things, so sorry, don't get too excited. I know we use 3 exclamation marks, but we can't get excited yet. A couple more things we have to do, but it's not to do with the scripting. But that's it. That's the script. Let's save it. Make sure it's saved. It's all in there. We're happy. Good stuff. What we need to do now, from the editor, we just need to set a couple of these things. Let's drag some objects into the arrays. Let's drag these BL and TR markers into their variables, and let's set all these values here. So, we'll get into that. Okay guys, we're on the home stretch now. The end is in sight, and we should hopefully have a victory soon, assuming I can remember all the correct values to set here and guide you accordingly. Okay, first thing we're going to want to do, let's take this world generator script, let's drag and drop it onto our world generator. Let's click on the world generator to bring it up in the inspector. Look at all this that we've got to set. Probably the first and most important, let's set these layers. So the ground layer, we want to contain ground, and we also, despite its name suggesting otherwise, is we want it to include the terrain. So if you remember in the script, when we check that ground layer by casting the raycast, we're actually looking for the terrain as well as the ground. Now it won't affect the terrain spawning, even though we are using that layer, because in theory, in the first pass, there won't actually be any terrain in the world for it to hit, so it shouldn't affect it at all. Where it becomes important is when we spawn those world objects, we want it to check for the terrain, so we're going to use it there. Terrain layer, we will just include the terrain, and the world object layer, we're going to include the world object. Nice and simple. Alright, let's go up to the arrays up the top. For trees, we have 2 trees, so we'll set that to 2. We'll just drag them in, like so. Stones, I've only got 1 stone object, so I'll just say 1, drag that in. And the BL and TR markers, we need to set those. So these are our objects actually in the hierarchy here. So they're already in our scene, but we'll drag them in all the same. So BL marker, TR marker. Okay, now these are all the variables that we need to set. So let's say world object rows and cols. Alright, let's say we want there to be also, as I explained, sorry, in the picture, our rows and cols. We are treating this grid as a square, so in theory there should be an equal amount of points in each row as there are in each column, despite the grid I've drawn here being different. Just bear with me and imagine that that's the case. So let's say, how many have we got here? We got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10, so we could probably split it up so that there's 10. Let's say that'd be a good way to do it. Alright, so let's say 10. Now that's for world objects, so it's going to do 10 little hops or increments along the world, and it's going to do 10 in both directions. Now that will mean that we get a fair few world objects spawning. That's good, that's what we want. Terrain, on the other hand, we probably don't. We want this to be a little bit different. We don't want tons of the terrain on this in the scene. I mean you might. It depends what terrain you have, but the terrain I have, I kind of don't. So I'm going to set that to say 6. So it'll do the check 6 times in both directions. Repeat passes. I'm going to say, let's say 5 for now. Current pass. That shouldn't be exposed to the editor. I think I might have stuffed that up. Bear with me. We'll probably actually want to remove the serialized field from that one. I think I've put that one in incorrectly. So I'll just go back into there, and let's just have a look. Current pass. I did. I put a serialized field. Let's get rid of that. We don't need to edit that. We don't set that. That's set by the script. Give that a sec to catch up, and that should disappear. There it goes. Good. Excellent. Okay. the world object sphere radius and the terrain sphere radius. Really, it's going to be dependent on the objects you've got as to what works best for you here. I can't quite remember what I originally had in as these values. I'm just going to play with it a bit and see what I come up with. So for the world object sphere radius, I'm going to put in, I don't know, 1. Let's try that. For the terrain sphere radius, now terrain's a lot bigger, so I probably want it to be spaced fairly far apart. So I'll put in, let's try 5. Let's just see how that goes. Now I think that's all there is to it. In theory, if we run this, we should have the result we want. So let's give it a go. I'm just going to pause that. It's just, actually probably doesn't matter. Where's my camera? Camera. I'm just going to drop that a little bit because we want to sort of be able to see what's going on. I'm probably going to switch back to the scene view anyway, but whatever. I'll drop that down a little bit. Move that over. Let's change its rotation a bit so it's looking down on the world. Just raise that up. Alright, let's give it a go. Please work. No, alright, I've stuffed something up. Let's have a look. An array index is out of range. That's okay. What have I done? Let's double click on that to get our error. Yeah. Game object new spawn. Terrain object.length. Okay, I've stuffed that up. Not a big deal. Let's sort of see. New spawn between 0 and... So terrain. I forgot to put some objects in the terrain array. That would be my problem. Go me. And I bet most of you guys were probably watching that going, he's forgot to put them in there. And you were right, damn you. Okay, so what have I got? I got 3 objects for the terrain array. So let's drag them in. We'll say the hill, hill 2, and hill 3. Which is just those lovely cubes and spheres that you saw at the start. Alright. That should be good to go. Let's give it another go. Fingers crossed. Oh, there we go. Something's definitely not right, though. That's okay. We'll fix it. We'll fix it right up. Let's see what's going wrong. I'm just going to work on it, change what I need to change, and then I think I'll come back. Alrighty peeps, sorry about that one. Got it all sorted. It was just a couple of little mistakes that I'd made in the script, so I'll just run you through those now. You've probably noticed a couple of them anyway. As I'm writing it, you're probably just like, oh man, you goob, you've got it wrong, change it, but I didn't. First of those, we're up here, just at the start of the coroutine, where we're defining the terrain start position. That should be, so it should be X, Y, Z. But as you can see here, I put Y. That's not good. Not what we need. Let's put Z. Good stuff. So that should fix the terrain spawning. I'll just show you very quickly. We have a look now. Oh, when it's done. There we go. It's behaving a bit better. Good stuff. The second issue was down... Where are we? So current path 0, here's the world objects. So the second issue was with the world objects. So in this else condition here, when we are incrementing, so this is incrementing the X, and this should be incrementing the Z. I've made a bit of a mistake. So this here should actually be current pos, and this here should be current pos as well. That needs to be correct because it needs to reset the X and go back to the start position. That probably didn't matter, that wasn't going to change, so whatever, but this needs to be current position. I was using the world object start position as the Z, so basically it was never going to move up the grid, it was only going to stay on that one row the whole time, which also is not what we need. What I've also done as well, these yield return new wait for seconds statements here, I did have a 0.01f, and that's fine, but it does run insanely fast. So what I've done is just change them to 0.1f instead, just so you can have a good look at what's going on. So if we save that script, go back into Unity, and I'm just going to run that so you can actually see it working. I'll just go into the scene view because I think it looks a bit nicer. And there we have it, spawning the terrain. And now it's going to start spawning the world objects. And zoom in a bit, and just have a look at that doing its thing. Some lovely trees there. So you can see they're spawning pretty far apart too. You'll get a better idea once it starts its second pass, which it's doing now. There is a fair bit of distance between those objects. But ultimately you can see it doing its thing. You can see what it's doing. It's starting from here, working its way along, and then repeating. And it is randomizing as well. You can tell that it's doing that because otherwise we'd have a nice straight line of objects. And that randomization is what's sort of scattering them around the world a little bit. And that's well and good. It's perfect. It's what we want. But as promised, I'm going to show you what happens when we start changing some of those values, just so you get a good idea on what they actually affect and how they work their way into the script. So the first thing we might do, probably one of the obvious ones, well, let's go into the script first, and I'm going to change this. I'm going to change these yield statements back to 0, 1. You've seen it working. That's all well, good and happy. Let's make it a bit faster now so we don't have to sit there and watch it each time. Save that. Let's go back into Unity. Highlight the world generator object so we can get to these variables here. And let's change some stuff. Okay, let's adjust the world object rows and cols first, I think. Let's bump that up to 20. So you sort of saw how spaced apart those objects were. Now if we increase that value, so tell it to more densely pack the objects into the world, let's see what it does. There we go, look at that. That's only the first pass, and already our objects are really close together. We got a lot of them going on there. So it's the increments are a lot smaller, then there's a lot more of them across our grid. So that will far more densely populate your world just by increasing that value. We still, though, as you can see, the objects are still fairly far apart. They're avoiding sort of getting too close together, and that's that sphere radius that we're setting there. So let's adjust that a bit. So let's go back to the world generator. Where is it? Where's this world object sphere radius? Let's drop that. Let's make that 0.1. Sounds good. Yep, sorry, I thought I hit insert. 0.1 is what we're going to make that radius now. Let's run it again. Back into scene view. Let it do the terrain. Blah blah blah, off it goes. I suppose it's not heaps noticeable, but I suppose there's one example already. Like, look at that. So the objects are getting a lot closer together, and you will see quite a few of them start to overlap. The trunks of the trees probably won't overlap, just because they are their own little collider there, but the actual tops of the trees probably will because they're significantly bigger, and the sphere isn't very big, so it's casting it sort of, I believe, from about the center of the object. Yeah, no, I think, actually it might be a bit lower than that. I think it's probably closer to the base of the object where it's casting it, so the collisions aren't happening between the tops of the trees, they're only happening with the trunks of the trees, or at the base, which isn't a really big deal. So we can see there, yeah, actually it might be the center, so the collisions aren't occurring between the stones and the trees. But you sort of get the idea. By adjusting that value, you can sort of make little, far more clustered groups of objects. Awesome. We'll end that. Go back to the world generator. Now what else should we alter? We can pretty much do the same with the terrain. So you sort of saw the terrain was fairly, there wasn't heaps of it. It was fairly spaced out. Let's bump that up massively. Let's put 20 terrain rows and columns and see what we end up with. Wait, there we go already. Now it's sort of going a lot slower, just basically because it is doing that check. It's using a fairly large sphere, and it is making a lot of collisions. So it is doing it 20 times, but because it's doing that check, we're not actually seeing them spawn. What I can probably do, let's make that a bit more visible. Let's drop that terrain sphere radius down. Let's make that 1. Now we are going to see some overlapping though. There we go. Whoa, look at that. So yeah, that's going to take a while. Doing its thing, off it goes. But you get the idea. I might just quickly check this. So I've got the terrain still set to 0.1. Let's make that 0.01f there, and just do that again. When it lets me. Come on, Unity, wake up. There we go. It's a bit faster. Whoa. That's fair hideous though. It's not very... Well, I suppose it depends. Depends on what you're after and what your objects are. which is not so bad. This looks a bit more natural, I suppose, as far as you can with these objects. You sort of get the idea there. So the rows and cols values will affect how many of those objects spawn, so how far apart the increment amounts are and how many of them there are. So obviously the more rows and columns you have, the more of those points of increment there will be, and the larger the sphere radiuses, or the smaller the sphere radiuses, will affect how close together the objects can spawn. So you could set the rows and columns value to like 100, but if you've still got a large sphere radius, it's not actually going to spawn that many objects. They still need to check and make sure that they're not colliding with other objects. So as I could probably even show you, let's give that a go. It's probably going to hate it, but I'll give it a try anyway. I'll set the world object sphere radius to let's say 10. And I've set the rows and cols to 100. I'm going to drop the terrain rows and cols back down to 6, just otherwise it's going to take a while. And I might set the terrain sphere radius back to 5. But yeah, importantly, we've got 100 there for the world objects rows and cols, and we've got 10 for the sphere radius. So you should see this actually in effect. It will appear to take quite a while, but so even though the world should be ending up fairly densely populated, it's not doing it. Just mostly because the sphere radius is too large. It's not going to spawn those objects. There you have it. So let's drop that back down to 1. Let's try it. Unity's probably going to get real cranky with me, but I'll give it a go anyway. And there you go. Look at that. So once again, it also impacts the randomization amount. So because those increments are less, the randomized values are less. They are still randomized, but just in a much smaller area. So basically, if you wanted to achieve a lot of objects in the world, but you don't want it to take too long, there is a way to sort of do that. So adjusting the increment amount, the rows and columns amount, although it will give you more objects, is not the best way to achieve it. Let's set that back to 20 was a good value, 20 was working. If we want a lot of objects, but we don't want to be waiting for ages, you saw that was taking a long time. Each row is going to take ages. The best way to get even more objects without lagging down the whole process is to adjust this, the repeat passes. So instead of 5, let's set that to 20. When we run it, the rows are still going to happen quickly. There we go, they're doing their thing. You probably drop that value to make it run a bit quicker, but whatever. And now it's going to do that repeat pass again. So this is a much quicker way of achieving more objects in your world. Play with those values, see what works for you. Like I said, it's going to be dependent on the objects you're using, the models you're using, all of that, as to how you sort of structure this script or how you want those values to work. But this ultimately should give you a nice base to start with, something to work with. And I hope that you've sort of understood how we've structured that script, how the functions are working, and just what we're doing here today. So as always, guys, really appreciate you taking the time to watch this video. I know they're long, and I do apologize. I know I ramble a bit as well, but I really just want to ensure that you guys get the knowledge you need, that you understand what's going on, and that hopefully you're learning some stuff out of this. As always, if you've got the time to give us a like and subscribe to the channel, that'd be really good. I'd really appreciate it. And yeah, thanks for watching. I'll see you next time.